So the next topic would be illustration of phases. So we are considering one component diagram. So in this we are taking an example of water. So if we take water, if we cool down that water, then we are getting a solid state of ice. If we maintain as it is in the room temperature, then we are getting a liquid state. If we are heating up to a temperature around above 100 degrees centigrade, then we are getting gaseous state. So there are three phases can be obtained with the help of this element. So in this, we may have a example of salt which is going to be mixed up with the water. So a solute of salt which is mixed in the solvent of the water. So it is completely mixed. That is a mixed solution which we are getting as salt with water. Then oil and water. So in this diagram we may able to see that the oil and water, there are two physical elements. There are two elements are presented inside this container, but there is no virtually solubility between this oil and water because oil is above the water surface, so that it is not mixed together. Let me consider about the phase diagram of a pure substance. That is nothing but one component phase diagram. So here we are taking the component, one component is water. Okay, in the previous example what we have seen is water as a one component diagram. So here we are considering the same element. If we are considering 0 degree centigrade, so this is 0 degree centigrade, 0.007 degrees centigrade, that means almost to 0. So up to this point, this water will become in the solid state of ice, and up from 0 degree to 100 degree centigrade. So in this state, up to 40 degree, it will be in the partial, that means liquid solid solution. Another that completely liquid solutions. So this is nothing but water, a complete liquid state. Then above that water, that means if you are continuously increasing the temperature, then this water becomes a steam component. That means it is considered into water vapor condition and gaseous state. Above this critical point, it goes to the gaseous state. So this is the phase diagram of one component diagram. One component. So the next concept is Gibbs phase rule. What is meant by Gibbs phase rule? Gibbs is a scientist who is going to give a phase rule for understanding the degrees of freedom. That means with the help of this formula, F is equal to C minus P plus 2. The number of phases present in any alloy depends upon the number of elements of which its alloy is composed. That means F is equal to degrees of freedom, C is equal to number of components, P is equal to number of phases present in this system, 2 is the variables. That means here how many variables are there? Pressure and temperature. So there are two variables are there. So 2 is the number of variables. That means degrees of freedom, number of components, number of phases present in this system, and 2 is number of variables. It is a constant value. So with this help of formula, we may able to find out number of degrees of freedom. If we consider this example, okay, we are going to apply the formula to this example. If we consider this triple point, what is this? This is triple point. In this triple point, we are having solid, liquid, and gas. There are three phases are there. Three phases are mixed with this point. That means three phases are coincides in this point. So in this point we are having three phases. So for this triple point we are going to apply the Gibbs phase rule. If we are going to apply the Gibbs phase rule means F, we don't know, F that we have to find out is equal to C, number of components. How many components in this system? It is a one component system because component is a water. There is no any other alloying elements over there. So only water, we are taking only water. So it is a one component system. So C is equal to 1. Then P, number of phases. how many phases are present in this system for triple point? Solid, liquid, and gas. So there are three phases present in this triple point. So 3. 1 minus 3 plus 2. So what is the answer? 1 minus 3 minus 2. Minus 2 plus 2 is equal to 0. So for this triple point, there is no degrees of freedom. So this could be the answer for the while applying Gibbs phase rule. The same Gibbs phase rule is going to apply for this line if you are considering this line. Okay, we are considering this line. Then what could be the Gibbs phase rule value? What could be the degrees of freedom? Let me check. F is equal to C minus P plus 2. The same formula. F that we don't know, that we have to find out. C, number of components. How many components? It is a single component system. So C is equal to 1. There is no change in it. P, how many phases are there? For this line, how many phases are there? One is water, another one is water vapor. So there are two phases. There is no liquid. Okay. So for this line, we are considering only two phases. So water. So two phases. So 1 minus 2 plus 2. So 1 minus 2 is will be the minus 1. Minus 2 plus 2 will minus 1 plus 2 will be the answer is 1. So number of degrees of freedom would be 1 for this line. For triple point, we are getting the number of degrees of freedom will be 0. For this line, the number of degrees of freedom will be 1. It is a unary system. Likewise, we are going to apply this Gibbs phase rule wherever it is possible and wherever we need. So by applying this Gibbs phase rule, we may able to identify how many degrees of freedoms are there in the system. Thank you.